Professor Dr. Khairul Anwar from Telkom University, Indonesia, and also Mr. Muhammad Ahsin Muflihun, PhD from Universitas Gadjah Mada, Indonesia. So in this agenda, we are going to hear the speech from our keynote speakers that will be moderated by Mr. Sudarisman, PhD. So to Mr. Sudarisman, the stage is yours.
Good afternoon, ladies and gentlemen, and to those who are Muslims, Assalamualaikum warahmatullahi wabarakatuh. We will have two speech this afternoon. The speaker will be Associate Professor Dr. Khairul Anwar from Telkom University. His educational background is he holds BEng from Institut Teknologi Bandung and master and doctoral degree from Nara Institute of Science and Technology, Japan. And also some professional background include in IEEE and also some other professional groups. His interest is in the field of electrical engineering and telecommunications, and he will talk about advancing telecommunications, pioneering insight and wireless communication and network technology. And the second speakers will be Dr. Muhammad Ahsin Muflihun. His educational background, he holds BEng from Gadjah Mada University and MSME from the LaSalle University and PhD from the University of Tokyo. His interest is in mechanics of composite materials. And this afternoon he will talk about the interconnection between composite laminates and additive manufacturing. Ladies and gentlemen, this afternoon we will have time until 3 p.m. After that, we will move to another building just across this building to the south. So we will have about 100 minutes. So for each of the speakers, I will allocate time about 25 minutes each, and the rest will be for discussion. So first, we will invite Associate Professor Dr. Khairul Anwar. The time is yours.
Test, test, test. Okay. So while we are waiting for the switch from camera to my computer screens, so first, Assalamualaikum warahmatullahi wabarakatuh. And thank you very much for a very nice introduction from our moderator, Pak Sudarman. Yeah. Yeah, Sudarisman. Yeah, thank you very much, Pak Sudarisman, for the introduction. And also, I would like to thanks to all participants and also the committee who invited us to be here. I do hope that even though it is around 1:20, I think this is almost the sleepy time for many people. But I do hope that everybody can enjoy this talk. Actually, I have 25, not 25, but 51 slide. But the time is only 25, so maybe I will skip some slide, and we can make a more interesting question and answer later. Yeah. Oh, di sana boleh. So because the lab.
Okay, yeah. Which one is more convenient for you?
Yeah, so I think I should be here and then I can see the slide. Can I see the slide from here too? Test. Test. Okay, so while we are waiting for the slide, everybody, actually I would like to talk about the development of the 5G advance and also the 6G and the challenge that we can make contributions. Yeah. And then to the second speaker, Pak Aksin. So maybe we have a little bit different topics, but I do hope we can still make connections between them. Okay, so 5G has been released in 2020, and then 5G Advanced will be released in 2025. So we have about 2 years from now on to 2025. And then the main technology, the main benefit or the main expertise that we should have to make development on 5G advance is on artificial intelligence, yeah, but almost for signal processing. So AI for signal processing, it means that at the lower layer, if we see the OC7 layer, so maybe in the data link, yeah, a physical layer, and then data link, network, yeah, and transport, maybe at around that area. But many people understand the AI will be used in the upper layer, but in 5G advanced will be in the lower layer. So that's the first point. The second point is the 6G. The 6G will be released, yeah, by the 3GPP, and first will be released by ITU. The commercial of 6G will be in 2030, and then 6G has at least 6 use cases, but the main difference between 6G and 5G advanced and also 5G is on the security, and then the security will be based on the quantum cryptography. Okay, so we have the slide now. Okay, can you go to the first page? You cannot. Okay, we have the slide, but now. Okay, yes. Okay, so everybody, the title is the 5G Advance and 6G technologies of intelligence and security for life. So I put life there because our topic is sustainable humanity. And then the keyword of the 5G advance is intelligent, and the keyword for the 6G is the security. That's why I put intelligent and security for life there. Yes, and I am Khairul Anwar, currently the director for the University Center of Excellence for Advanced Intelligent Communications in Telkom University, and I am also the vice chairman of Asia Pacific Wireless Group. And then just 5 minutes ago, I made a final meeting with the Ministry of Kominfo of Indonesia, Communication and Informatics of Indonesia, to prepare our meeting in Asia Pacific Wireless Group for the preparation of World Radio Congress, World Radio Conference in 2023. And then currently I am also working on the quantum technology under the collaboration with PKR Quantum 2.0 together with ITB and BRIN. And then I also received the international funding to develop 6G and build the new laboratory we call 5.5G laboratory there. So I do hope that this is a very good time for us to meet here and to discuss about what we can contribute to the development of 5G advance and 6G. Next. Next slide. Okay, so I returned back to Indonesia in 2016 after living for about 14 years in Japan. And then I built the new laboratory we call Advanced Wireless Technology. The first funding are from UK and also from Indonesia. And in 2020, we are assessed by the Ministry of Higher Education, and we receive the level of Pusat Unggulan Iptek Perguruan Tinggi or National University Center of Excellence. Yeah. And we changed the name into ICOMS. ICOMS is standing for the Advanced Intelligent Communication, where we are focusing on intelligence for communications, preparing for 5G Advanced and 6G. And then, starting from 2020, our funding more than 4 billion rupiah. And we are expecting that this funding budget will always be increasing, and we can utilize for the development of research and implementation of technology in Indonesia. Next. Yeah, this is, even though this is our philosophy, but I think this is also important for us that we understand what is the root of the topics or the field we are expert on. So the first, our root is information theory, machine learning, and signal processing, coding theory. But we also provide the product, application, and also devices as the fruit of that tree. And then we are focusing on classical electromagnetic 75%, quantum 15%, molecule 5%, and also optics 5%. So almost all channel or medium of wireless communications we are working on. Next. This is our 5 top products. So the first is 5G Merdeka, and the second high-speed train, where we develop the Doppler spread compensator to compensate the Doppler effect when we have speed of 5G railway about maximum until 500 km per hour, and for the 6G 1000 km per hour. And alhamdulillah, we solved that. And what we need the next is the experiment, but I do not know how we test the speed of 1000 km per hour in Indonesia. But this is our homework. And then we are working on over-the-horizon communications, next generation IoT, where our throughput is the highest among them, 0.9 until 3.7 packet per slot. And we are also working on the AI, quantum error correction coding, and also the future security. Next. This is our successful experiment of 2G, 4G, 5G at Telkom University, and then with the emerging technology of 5G advanced in 2025 and also 6G in 2030, we are also expecting to develop that and also make experiment in Indonesia. Next. This is the top 10 of the prioritized technology we propose to the Ministry of Communication and Informatics of Indonesia, and Alhamdulillah Kominfo accepted this top 10 technology, and the first is the 5G NR, 5G Advanced and 6G. The number 2 is Wi-Fi 6E and Wi-Fi 7, and number 3 is railway, and then after that IETS, and then UAS, and then high throughput satellite, IoT, quantum satellite, and also hybrid eSIM, and then wireless power transfer, hubs and HIPs, and GMDSS, and also EESS or exploration satellite. So those are technology I think that we should be an expert for that and to implement as soon as possible in Indonesia. Okay, so how much time I have? It's okay, I continue? Yeah. Okay. So I will make it faster, but even though I will talk faster, but okay. Everybody, at least please understand the philosophy. So in this point, I give the title Cognitive Blind Spot, our current complex words. So we know that our word now are becoming it's becoming more complex because of many change of the people, change of the technology. So first, there are 2 points I would like to highlight in this slide. The first is what Nikola Tesla said: when wireless is perfectly applied, the whole earth will be converted into a huge brain. I think even though he lived between 1856 until 1943. This is just 2 years before Indonesian independence, 1945. But what he thought, I think this is correct today, with the development of artificial intelligence and the development of wireless communication, and then the earth here will be a big brain because of many self-organized technology for the network, for example. And then the second point is that our social complexity, maybe in the future will be higher compared to the cognitive capacity. Cognitive capacity means our capacity to understand something. So maybe, in some sense, complexity of our life is higher than our capacity to understand. So this can be impact 2 things. So the first, maybe this is also a challenge to give innovations. But the second is that we do not understand even our word. So maybe this is the first thing I think that we need to understand. Next. Let's go back to the law of the physical world. So we have the 3 important laws here. So the first is the Newton physical world, which we call the classical mechanics. So we know very famous formula of the F equal to M multiplied by A. And then we also know the Einstein cosmic word for general relativity, where energy is equal to the mass multiplied by the speed of light, power 2. And then, but we usually do not know is the law number 3. The law number 3, after we talk about our world and then our universe, but we talk about very small thing. So what's the small thing is that the subatomic world, which we call the quantum mechanics. I wrote there, I refer to that book, the Quantum Finance 2020, where the Hamiltonian ket psi equal to the E ket psi. So I think this will be the keyword to understand our complex words and also to understand where we can make contributions. Next. this is just very short, that we can implement the third law, yeah, even for quantum finance, where we can predict the rate, for example, using the double slit experiment, extended double slit experiment, so we can predict the change even maybe for our complex words, not only for the finance, yeah, but for others, we may also use the Feynman path integral. So when we make the more slit and more layer, then we can predict the change of the line. Next. In this slide, I would like to say two things too. So the first is the trend of the telecommunications, yeah, are changing, yeah, almost at every 10 years. So we completed 5G in 2020, and we will be having 6G in 2030. And in between, we are having 5G advanced. And then the 5G will be the end point of the first S-curve. So S-curve is the innovation, and then impact to the economy, and then saturation. And then the next S-curve is the photonic divine radio, and the next S-curve until 8G is the quantum radio. And Indonesia 2045 will be between 7G and 8G there. And then the question is that what we will do. We will make contribution, or we just wait the innovation from others. So I do hope that we can make contribution by understanding these the phenomena. So the second point is that because on the S-curve, yeah, are about 3, or maybe if we combine number 2 and number 3, so we have 2 S-curve, then we may have the many new resources when we move from the classical electromagnetic into the new domain, which we call the quantum domain. Because as I wrote there, that the y-axis, this is the complexity or resources, and the x-axis, this is the size, or the number of bit or the number of qubit. Then the quantum machine, yeah, outperform the Turing machine at some point. And I think this point will be coming soon, within between 2020 until 2030. And then World Economic Forum said that the 2030 will be the line where after that will be the danger zone. I will show the slide there. Okay, next. Okay, so this is 1, 2, 3, 4, 5. So 5 points concerned by the ITU standardization sector until 2024. So the first is artificial intelligence, machine learning, and the data. The second is environmental sustainability. So this is, I think, correct with our topic of conference. And then metaverse, and then quantum information technology, and then 5G and beyond. So I think our topics now are, yeah, in line with what ITU is talking. Next. After that, everybody, let's see the convergent point. So I saw the 3 lines there. So the from information revolutions, yeah, will converge in the metaverse, and then from the industrial revolution also will converge in the metaverse, and then the energy revolution will also converge in the metaverse. So maybe metaverse or multiverse will be the convergent point, yeah, in the next year. Next year mean in the following year, maybe 10 years or 20 years later. Then next, in line with that, I would like to introduce to everybody that we are already moved from ICT sector, talking about the connectivity, to the digital economy, yeah. And the next is the digital first economy. So what makes the difference is that when we are talking the digital first economy, it means that the digital technology or the technology itself is by design only for digital world, not for the analog world. That's why we call digital first economy, of which the main technology will be gigabit broadband, metaverse, ubiquitous connectivity, quantum cloud, pervasive intelligence, autonomous system, renewable energy, clean ICT, and data government for value creation. So that will be the the next digital first economy. Next, this is what Japan prepared for the quantum in June last year. So the Fujitsu and RIKEN made joint research and developed the quantum, but I think the number of qubit here is still 64 qubit. Yeah, not so much, but I think this is already a good start. So the question to us is, what about our country? So I do hope that our country is not being late for this technology. The next, IBM. So the plan of IBM is until 2026 to develop not only 64, but I think here until more than 2024, 1,300 qubit. And then I think until 2026, they try to develop number of qubit more than 10,000. So this is a very, very challenging task. Next. Okay, so with the development of the quantum, everybody, the telecommunication is also changing. So at the left-hand side, this is what I developed during I was in Japan. So I tried my best to prove that line, but with the change of quantum, I should change again. The theory is changing. So at the left-hand side, they are belonging to the classical, but for the quantum, the equation will be different. Especially, for example, if you know the conditional entropy, for the quantum, conditional entropy can be negative, while in classic, no, always positive. So that's changed the theory too. Next. So this is the thinking for the 6C, everybody. When we talk about the quantum with respect to the radio access network, then there are 1, 2, 3, 4, at least 4, maybe 4 technique that everybody should understand. So the first is the quantum Fourier transform. So the first line, first picture, this is the quantum Fourier transform for the 3 qubit. And then the second is the quantum K-means algorithm. It means the quantum machine learning for the classifications. And then the third is the quantum support vector machine. And the number 4 is the Grover's algorithm for the big data. So I think with those technology, and then the future telecommunication will be also changing. Next. This is when the quantum meet artificial intelligence, then we can implement that for the drug discovery, data encryption, for the logistic, and also, of course, for the big data, including security there. 3 more minutes. Okay, next. This is the update from the Barcelona last time when I visited Barcelona for the World Radio Congress. So Mobile World Congress. So Rode and Swart has developed the artificial intelligence for the receiver. So we do not need anymore the turbo decoding or Viterbi decoding using the traditional technique, but we can replace them using the neural network. And then for the security, at the right hand side is mainly based on quantum, because in quantum the state cannot be cloned, so it will guarantee I mean by the knowledge of the current knowledge that the information is secure. Next. So this is everybody the study from the World Economic Forum, saying that after 2030 will be the danger zone, because the quantum computer after 2030 will be in high performance. So when the quantum computer will be in high performance, then with the Grover algorithm or with Sol algorithm, almost all security can be break. Next. So this is the prediction. So with the Sol algorithm, the quantum computer can break within 0.01 second, while if you are using the current computer, you need 4 times to 10 to power 134 year. It means that more than 10 years you need to break the security, the existing security, but with the SOR algorithm only 0.01 second. So the question is that what about the technology that you cannot update, like the satellite, because the lifetime of the satellite is usually more than 20 years. After you release the satellite to the sky, yeah, to the deep space, then how you update? So this is the question. Next. Pak, how much time I still have? Or if not, and then I just want to show. Please, 1 more minute. Okay, next. Everybody next. 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 I just want to talk about 6G. Next. 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 Okay, okay. Okay, so everybody, this is the, oh, I forgot to put the citation. This is from ITU, just released in June 2023, so just about 1 or 2 months ago, that the 6G requirement has been decided, because it is decided, and then I think everybody can start working to satisfy this requirement. So the first, the usage scenario, at the corner that you have the triangle. Triangle is actually the target of 5G, but for the 6G we have the 3 additional use case. So the first is integrated AI and communication. So AI and communication will be joining. And then the second is ubiquitous connectivity. And the third is the integrated sensing and communications. And then the 6G will have the new capability. It is shown in the blue color there. And then also having the enhanced capability showing in the green color. So those new capability, new requirement from ITU, I think we should study that and then make contributions from Indonesia, that we also develop the technology from our innovation and also research in Indonesia. I think next, because I don't have time, I will discuss that in the question and answer next. Okay, so I still have more, but the time is up, so let's make a nice discussion in the Q&A. So again, thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Associate Professor Dr. Khairil Anwar. The talk is very interesting. It's about quantum technologies in our time to heading to convergence point of our life. The second speaker will be Dr. Muhammad Ahsin Muflihun. So the time is yours.
Okay. Thank you very much, Dr. Sudarisman, to let me in, and after Associate Professor Khairul Anwar. So I think the mic is on, right? So I will talk about I think this is the story of our groups, indeed, because we are just started like 3 years ago. So we will try to talk about how we can develop from the scratch the facilities, the environments, and then how we can build the communities that we can not only educate the young Indonesians in higher education, but how we can build like reputable laboratories, and then it's also a high reputable journal for that. So this is the title. Let me stand here because I feel better sleepy, so when I stand, I will not be sleepy. So our title is the interconnection between the composite laminates and then additive manufacturing. The composite technology is already, I get the technology itself from when I was a PhD student in Japan. But when I come here, everything is gone, like, you know, like the facilities and then the equipment is almost nowhere in here. So what we think is about how we can get not really expensive technology, but we can affordable, and then we can build step by step, so we can also achieve the higher level for the research. So that's why we choose the additive manufacturing compiled with the composite technology. So, and I'm from the Mechanical Industrial Engineering Department from Gajah Mada University. So next, please. So my research actually from composite manufacturing technology and additive manufacturing, that we also use failure analysis and micro, nano manufacturing. And just now, currently, we get funding from LPDP that we need to recycle for the battery lithiums that usually used in electric cars. And that's my education. It's not so important. So next. Yeah, this is the members that we just take a picture in the, I think, 2023. I think some of them is already staying here. So currently, at the times, we got like one postdoc from NUS. He staying several days in our labs doing some research, and then the other one is like Pakistani master student. So next, please. So here, the background of our research. So actually, composite manufacturing is divided mostly from the material itself. So there is a continuous fibers, then carbon fabric or glass fabrics or Kevlar fabrics. You can name it when you combine it. Then chop fiber. Chop fiber usually that when you make something and then the scrap of the fiber is also can be used to strengthen the structures or the laminates. Then also this is the most industrial and technology in composite is about prepregs. Prepregs currently not only carbons, we can use glass fibers, or sorry, glass prepregs, Kevlar prepregs, or even natural fiber prepregs. So there is many applications how we can manufacture it. We can use filament winding and then RTM, VARTM, hand layup, compound and autoclave, and then the roll wrappings. So, and then we can see that the application of the each manufacturing process. After this, so what we did in our lab, so actually among the 5 cluster, we only did 2 manufacturing process, which is via RTM and then the filament winding or the hand layup process. So next. So that's our, it's not really detailed. Okay, so what additive manufacturing? So there is 8 additive manufacturing technique that we actually in this work doing, from the fat photopolymerization, material jetting, until like there is a material extrusion or FDM, material DIW and powder bed fusion and the others. So what we did in our labs, so you can click one more. Yeah, so actually we only use 2 as well because it's ready in the market and not really expensive. We can build or develop. Okay, next. Actually we have a collaboration with Brin. However, the machine itself is not in our labs. It's metal 3D printers, so it's not really in touch with our research currently. So this is what we did. The combination of fiber and 3D printing are capable to increase material properties and prevent the failures. This is based on our publication, the recent publication in 2023. So in the up figures is how we can combine the additive manufacturing with glass fibers. And then the below one is how we can, actually this is a new things that we can combine the fat photopolymerization and FDM process. And next. So this is the fundamental breakthrough. So you can click again. Okay, so the process is start from 2019 when we first publish our papers in hybrid laminates, and then in 2021 we start to doing FDM process that we can successfully imitate and improve the sound quality of the music box. So actually during that times there is no one in our labs. So we just trying what kind of idea that we can produce and make something novelty in our labs. So that's in 2021, and in 2022 and 2020 when it's pandemics occurs. So we also have one publication is related to how we can combine the carbon fiber with the metal laminates. So the next, please. That's around 2020 and 2021. Then we continue to develop the fiber composite laminates combined with the like additive manufacturing or 3D printers. Yeah. So because we also get several fundings like from Ikura technology from Japan and then from JICA, how to improve the quality of the research. So we can remodel and additively manufacture the, like, it's still the outdoor equipments, the carabiners, where they evaluate and characterize it. Then we also use economic aspect when we can incorporate with the composite laminates technologies. Okay, next. Yeah. I think just last year's. So we try to not only develop, but we can collaborate with the others parts. So we have a publication with the brains, how we can use laser powder bed fusion. It's like the metal 3D printers that only like several companies in Indonesia have, but also we also doing metal 3D printers, or we incorporate the VARI vacuum assisted resin infusion in our technologies. Okay, the next. So this is the pros and cons. So what is composite manufacturing and additive manufacturing? So actually the process itself is quite different. When one the others, we can use 3D printers, how we can build something from the zero to the like something that we want to create, and then the others is composite manufacturing is already established. So for example, when we see the Airbus or Boeing's planes, the newest like Airbus A350 or Boeing Dreamliner's 787, that's more than 50% use composite materials. So how we can incorporate this composite material in the more basic application that we can do it. Like for example, in automotive or the others, is like outdoors equipments. So this is the pros and cons. Okay, next. So this is from 2023 and go on until 2024. So yeah, we still build our research facilities, and then we also publish, we think that that's a good reputable journals. And then what we did now and what we do now in the process is how we can use a bio-based material in hybrid laminates and how we introduce it. And then how we can make a new model in hybrid laminates and the structures with the crashworthiness effects, and then the defect of the hybrid laminates also we develop it. Then in 3D printers, the lamination of PLA model with the GFRP is also, we try to introduce and evaluate it. Then, next. Yeah, this is the sum of the publication that we publish. So, I will talk about the core of the speech today. It's about what we try to develop the additive manufacturing combined with composite laminates. So we have two publications. One is about carabiner, and then the second is figure 8. So why it's called figure 8? Because the figure is like 8 numbers. So figure 8 is a tool that used in outdoor activities, usually for climbing, and then or mountaineering. This tool used to lower the climbers from the vertical cliff. So if the climbers want to like going down from the cliff, so they usually use figure 8. So what we did, usually figure 8 that we can get it in the markets is made by the metal. So how if we want to make a new things, the figure 8 that make a new from the additive manufacturing, and then the other one is from composite laminates. So first of all, we need to design the figure 8 itself. So the design is quite simple. We make a design and then we print it in 3D printers. So what the novelty of this research? So next. So we not only copy and paste what the figure 8s already in the market. So we also want to doing a new design, how we can make a new model of figure 8s. So we have 3 models. The left one is already existing in the market, but the others is new things that we develop in our labs. So after we develop and then we doing a manufacturing process, then we do a testing from the tensile and then hardness, surface roughness, and also the density itself. Then next. So here are the result. So from tensile performance, we can see the odd numbers of the hybrid laminates. So what the difference between blue and then orange? When the blue is only PLA models that we manufacture by using 3D printers, and then a hybrid when we cover it with the glass fibers, reinforced polymers. So we can see that almost 100%, like 2 times higher the tensile performance. Next. In here, the hardness. So we can see the hardness is also similar with the tensile process. We can see that the design 1, 2, and 3, when we cover the 3D printer models with the hybrid laminates, we can see the hardness is higher than the PLA models. So in here, we can see that the GFRP lamination process can increase the hardness of the models of the laminates. And after the test, we can see that the both of the PLA base and then the hybrid base material have same, or we can see that similar indentation process. So we can see from the blue circles, almost the indentation is similar. What the difference? The difference is in the diameter of the indentation, where the hybrid model have a diameter less than PLA models. It means that for the hybrid models, we can extend the strength of the laminates, and then the ductility of the model is also can be stand compared with the PLA, the pure PLA. And then next. So how about the surface roughness? So if you want to check our surface from our products, in the 3D printer models, usually they have like a peak and valley and then peak and valley, like the B models. Like we can see the peak and then like going up, down, and up, downs. But when we combine it and then we can use the hybrid laminates, the surface is not completely can be predicted. So the surface is more like follow the glass fibers laminate itself. When we compare it with the B, it's like pure PLA, and then the C is like we combine it or hybrid laminates. Then next. So the density itself, we can see the density for the design one is like 1.2. It's not really changed the differences. So for example, for each design, when we tested, 3 parts were taken, and then the results can be seen in here, that the density is going smoothly higher when we applied hybrid laminates compared with the pure PLA laminates or PLA model from 3D printers. Then next. So we also incorporate with the cost analysis in here. Yes, we can improve the strength of the laminates using composite laminates over the PLA model. But we can see here the cost is also higher. When we compare the cost from the PLA design and then the hybrid designs, we can see the the design one is the highest models, the highest for the cost compared with the design 2 and design 3. So in here we can see that the hybrid design for the design 2 have the most economical, and then they have load, and then the total price is lower compared with the design 1. And then the design 3, they have a higher load compared with the design 2, but the cost is lower. So we can say that for the design 3 have a better quality, and then the cost is lower compared with the other design. So next. How about the failure analysis? So after we did the tensile test, we can see that in each model, the failures taken in the same place. For the PLA model, we can clearly see the crack of the models compared with the hybrid laminates. So in here, why composite is take apart can increase the strength and save the cost. When we choose the correct models, we can prevent the crack or the failure until 2 times higher. So the crack for the hybrid laminates is changed. It's not in the middles, but that's like somehow shifting, not only in the middle, but a little bit in the left of the models. Next. Yeah, I think this is the last from us. So how the result from tensile? So we can see that the tensile test results show the GFF relamination process in figure 8 can increase the tensile load of each design. And then we can see that the highest is almost 5,000 Newton or 5 kilonewtons. And then how we can get the best combination? So we can see that the design 3 have efficient is like 2.5 higher compared with the other models. And then how about the cost? We can see that the cost is higher in design 1 at 1.45. So it can be covered by the best performance during the tensile test. So I think that's, next is already finished, right? So that's all my presentation. Thank you so much.
Yeah, thank you very much for Dr. Asin. The time is about 20 minutes. He talked about developing a product using composite laminates and additive manufacturing. So our time now for discussion. Please raise your hand and say what's your name and to whom you address your questions. Okay, we will start with the first term for this question for 3 persons, please. Questions? Okay, 1. 2 more. Okay, 2. 1 more. No? Yeah. For the first term, we have 2 persons. Yes, please. First one.
Bismillahirrahmanirrahim. Thank you for the time. My name is Abdullah Irfan and I am a mechanical engineer alumnus from Universitas Muhammadiyah Yogyakarta. And what I'm going to ask is for Associate Professor Dr. Khairul Anwar. As we know that information technology is one of the most fastest technology, the fastest field that experiencing development there. Also, for the development, we also need the supporting unit for the information technology development, like new material or new building and etc. And what I want to asking is how we, as non-information technology engineer, like mechanical engineer or civil engineer, electrical engineer, can be included or contribute to the development of the near future communication technology. I think that's all from me. Thank you for your answer.
Okay. Next, please.
Thank you, Mr. Sudarisman, for the chance. I have questions to Associate Prof. Khairul Anwar and Mr. Muhammad Aksin. The first one about the communication technology, because I saw before in your slide, every 10 years the communication technology changes, and with the S-shape, that means it will saturate when it reach the end, and then change to the new technology. And in that slide, it's predicted that in 2050 it will use different technology. I forgot the name, but it's somehow related to photonics. Yes. Yeah. How it comes into these conclusions? I mean, is there any other alternative technology that may be used in 2050? And because we will still have a lot of time, like 30 years, 25 years, or 27 years to be at that time. So that's my questions. And then my second questions to Mr. Aksin. Because my background is from electrical engineering, so I had some difficulties to follow your presentations, but in the end, it's clear for me, a bit clear for me when you give the examples of the figure of egg. So my question is, did you compare the figure of egg with the same design between the metal that usually used in figure of egg and your materials? Because I don't know, usually if you want to compare, then we need to do it apple by apple. So of course in this case with the same design. So did you make these comparisons, or you just made a new design and then compare it with the other designs, the metal one? Thank you.
Thank you very much for Abdullah Irfan and Pak Faris. Yeah. Okay. 2 questions for Associate Professor Dr. Khairul Anwar and 1 question for Dr. Aksin. First, please, Associate Professor Dr. Khairul Anwar.
Test.
Okay. Yeah, thank you.
Yes, thank you very much, Mr. Abdullah Irfan for the question and also Pak Faris for the question. Okay, so I will try to answer the question one first. How can how can other fields are included in the development of the information and technology world? Yeah. Okay, so if the committee receive my file, would you please to show if you receive my PDF file, but if not, and then I will explain without slide. Okay, so like this. Actually, in the slide, I have shown the difference between each technology, starting from 5G, and then one, especially for the telecommunications. So the first, what we need is that infrastructure. What we are developing is algorithm, but in practice, after we complete the algorithm, we need the infrastructure. Infrastructure, for example, the tower of the antenna, and then the rack of the machine, yeah, and then also the fiber optic cable, yeah, to transmit either quantum photon, or we use the laser when we transmit the information, for example. All our algorithms require hardware. Yeah. And especially in the future when we are, okay, so the first is hardware, that the hardware is strong to the rain, strong to the, to the temperature, and yeah, strong to many things outside, because in general we will put outside. Of course, some equipment will be indoor, but in general, mostly outdoor. And then the material for the satellite, for example, also should be strong, yeah, against the atmospheric effect when we launch the satellite, for example. So, yeah, for the infrastructure, for the material, we need the strong material, and in the future, even stronger, because we do not know how the climate will change and how the environment will change. So in the future, we need stronger material. That is the first. The second, yeah, when we consider very high bandwidth, yeah, so our sampling rate should be very precise. And then usually it is difficult at the receiver. If we made a mistake in the sampling, then all signal, all information is gone. So the scientists, I mean the telecommunication scientists nowadays, we are using crystal. But I think in the future, if the material scientists can help us to find material that can do precise calculation, precise timing, then we need that. Yeah. So currently we are still using crystal as the most good material for synchronization. Yeah, so I think more we need precision in the future. So that is the second the challenge. And then the third, with the change of the technology to quantum, I think we need also the help from the physics. Yeah, from the physics, especially the quantum mechanics, yeah, to help us to control the qubit. Yeah, because the qubits in general, they are not robust against the magnetic effect, against the high temperature, and also yeah, at least those both factor will impact to the quality of the information when we transmit using the quantum. So as a conclusion, there are many challenges that we need the help from other field too. So don't worry to make contribution to help us in information technology. Okay, so the first question, and then the second question is to Pak Faris. The committee, can you show the slide? Oh, if not, and then and then I think I should answer without slide. So Pak Faris, I saw the 3S curve in my slide. So the first, this is for the classical electromagnetic, the second is for the photonic, and the third is for the quantum. Yeah. For the photonics, we already implemented using free space optic and also visible light communications. Yeah, and of course also the fiber optic already. But for the quantum, because we will be using the photon too, so we will also use the photonic technology too for the quantum development. So both technology will be required in the future. Your question is that 2050 or 2060 or 2070 are still far. And then how can we predict the technology from now? Yeah. Actually what we are doing is not only predicting, but currently we are having difficulty to have the wide bandwidth because the electromagnetic usually divide the wave from 3 kilohertz until 3 gigahertz. It is already full. But the human need more communications, need more high speed. So it is difficult for us. So which band we can use? So we need to increase to the higher frequency. And the higher frequency, the maximum frequency that we can use is the visible light, the sun, for example. This is around 300 terahertz. But beyond that, it is dangerous, like ultraviolet, and then Ronsen, and then gamma ray. So they are dangerous. So we cannot use the frequency beyond the visible light. So the visible light is the maximum frequency that we can use. Yeah. So we already know the trend that we are going up. Yeah, we are going up until those 300 terahertz, around 300 terahertz. But for 6G, it is predicted maybe at around 1 terahertz or 10 terahertz. It is predicted at around that. Yeah. So when we are dealing with the very high frequency, so we are having the difficulty about the radius, about the area, because the area will be very short if too high frequency, because the water in the air will absorb the energy. So we cannot use too high frequency using the classical electromagnetic, but we change to use the photonic technology, yeah, including that quantum. That's why the scientists are now starting to move from the classical electromagnetic to the quantum technology, quantum information especially. So I do hope that it answers your question. Thank you.
Yeah, thank you very much for the question. Yeah, that's the standard figure 8s can handle until 25 kilonewtons. When we use only PLA, it's only about 500 newtons, and or the maximum is like 1.5 kilonewtons. When we use the hybrid laminates, it can withstand until 5 kilonewtons. So actually, are it's comparable with the markets like figure 8s? It's not yet comparable because the standard is like 25 kilonewtons. But when we compare the weights, so the hybrids is more lightweight compared with the metals. And when we compare the capacity of the figure 8s, it's like 5 kilonewton is like 500 newtons, right? 5 kilonewtons is like 500 newtons. So it can like handle like 5 persons during like one movement. So I think that's not not yet being tested for like real climbing activities, but from our tests it can be used for one person is more than enough, like when we use in outdoor activities. But the problem itself, when we use many times, the figure 8s become like hot and then become more hot, and we don't net we not yet tested for the like we call it high temperature test. We not yet tested, but for instance for the like daily use, it also can be used for like climbing. That's yeah, that's also our target, how we can increase the strength of the models until we can reach almost the same with the markets, the figure eights. Yeah, yeah, you're welcome.
Okay, thank you, Vaksin. And in mechanic of material, we use usually term specific strength and specific modulus. That is strength to density ratio and stiffness to density ratio. So it's very important. Okay, that's the first term. And the second term, maybe 3 more persons. No more? Okay, one. Any more persons? Okay, so one person only. Yes, go ahead.
I didn't quite get, I didn't catch both of your names, so my apologies for the 4G pattern.
Yeah, Associate Professor Hairul Anwar and Dr. Asin.
Yeah, well, so my question is, what's the application for 6G that you can predict that 5G cannot do? So application for 6G that 5G cannot do. That's my question for you. Second question, have you looked into metal powder infused filament for your 3D printing project? That's the second question for you. Thank you.
Okay, thank you. Monggo.
Yeah, thank you very much. This is very good question and difficult to answer. Yeah, so like this. First, every generation, yeah, every generation they have the specific expertise, let's say expertise, or specific the most important things of each generation. Let's say for 4G, they improve what was the weakness in 3G. So for 4G, we change the technology into frequency domain processing, while in 3G, mostly in time domain. And then it is difficult and then more complex. We move to frequency domain, and then because we process in frequency domain, everything are very easy. In 5G, yeah, it improve what we don't have in 4G. So the first things, because I'm working on information theory and coding theory, so I know that 4G does not have the capability to adapt with the channel dynamic or channel variations. And then when you cannot adapt to the variations of the channel, then you are punished by the error. And then 5G improved that using the redless coding. What we call the QC LDPC, they can adapt to the environment, to the varying channel. So the first, and then the second, the bandwidth of 5G, yeah, it is the maximum until 400 megahertz, which is in 4G maximum 20 megahertz. So with 400 megahertz, then 5G can have the speed until 20 gigabit per second, while 5G, the speed is until 2 gigabit per second. So from 2 until 20 in 5G. That is the second thing. The third, yeah, the coding in 5G is more robust compared to 4G. 4G has the turbo code and convolutional code. 5G has QCLDPC code and polar code. And polar code is one of the technique that can achieve the Shannon capacity. Shannon capacity is the maximum capacity that can be achieved in telecommunication, and then it is achieved by polar code, and polar code is used in 5G. So 5G is better than 4G. And then, even though currently we have 5G, so we are trying also to develop 6G in 2030 with improvement first. Yeah, first the benefit of 6G compared to 5G now is that the throughput will be until 1 terabit per second, while in 5G only 20 gigabit per second. So 1 terabit per second, so we need about 1 gigahertz bandwidth. So bandwidth should be very large. That's why we are trying to move from classical electromagnetic into the photonic and into the light, based on optic, based on light. The first. The second, the security in 5G, it's based on the classical security, but in 6G, it is predicted to be based on the quantum cryptography. So it is more secure compared to the 5G. The third, the coding in 5G, maybe I am one of the person who know the weakness of 5G. So I am trying to propose the new coding rate for 6G that will improve the weakness in 5G. But even though in 5G has weakness, maybe with the current application, maybe many people cannot see that weakness. But for the future application, you can see the weakness. So we are proposing for this year, we are submitting for international patent for 6G. And we contact directly to the international vendor too to produce this, and inshallah we will also promote to the 3GPP, to compete with others, and the final will be the standard. I do hope that answers your question. Thank you.
So that's a good question, but the philosophy why we use 3D printer, especially in PLA and then composite laminates, we want to avoid the metals products, because metal products usually have heavier than composite products. That's at the end of the day we want to overlap the strength of the metals, but currently we can achieve until 20% only. So the working is still on the process. Like we change the fibers, we change the PLA with the others like lightweight PLA. But yeah, we try to avoid the metals because the metal itself is have heavier compared with the composite. Yeah. Yeah, you're welcome.
Okay, thank you. Any more questions? Okay, one. Okay, go ahead. One questions.
Okay.
Don't forget your name, please.
Okay, thank you, sir. So my name is Krishna Budiman. I'm from mechanical engineering from Universitas Gajah Mada. So I have a question for Associate Professor Koirul. So I'm interested in the topic of the Doppler effect. You said that you need an apparatus to test at the speed of 1,000 kilometers an hour. Is that correct? Okay. So if what are the applications of such speeds of the apparatus? Because from what I heard or from what I read, the current fastest bullet train available in the world only goes up to 500 or 600 kilometers an hour. So are you using it for making communications for fighter jets or something? I think that's my question. Thank you.
Okay, yeah, thank you very much, Mr. Krishna. This is very interesting. Actually, just yesterday morning, I saw how to manage the Doppler effect for more than 1,000 kilometers per hour. Yeah, and I was very happy yesterday. that using the Bessel function, we solve that, and using the array antenna, we can solve the Doppler effect, and then we can return back the frequency shift into the original. So I am very happy with that. So theoretically, it works. Yeah, and then by simulation, it also works. But we should test also in practice. So as I say that the problem is that how to test with very high speed such kind of things with Indonesia. I don't know if we can test that or not. And then talking about the applications, yeah, the 6G actually in the slide I wrote that the 6G is intended to support the communication until 1,000 kilometers per hour. The application is not for the railway. As you say that the current existing railway communication like Shinkansen has the speed of 480 kilometers per hour. Yeah, maybe another bullet train with the magnetic, maglev, maybe around 600 kilometers per hour. But 6G is targeting 1,000 kilometers per hour. So the target is for the communication not on the surface of the Earth, but for the deep space. I forgot the name. Maybe long distance LTH high mobility LTHMC. The terminology we use. Long distance high mobility communications. So for example, maybe the launcher to the deep space ship, for example, and then maybe also the Concorde, but I don't know, maybe Concorde is now closed or not. But the Concorde has the speed of 1,200 kilometers per hour. So maybe with such kind of application, we need to solve the problem of the Doppler effect for such kind of technique, or such kind of car, or such kind of ship, for example. But this is very interesting, and I just realized now, everybody, that once your speed is very far below the speed of light, we can solve, even just using the simple Bessel function. But I tried to simulate the train or spaceship close to the speed of light, and then when we set the v equal to c is 3 times 10 to the power 8 meter per second, and then all the Bessel function destroyed. I say that okay, so we should not approach the speed of light for the ship, because all our prediction is becoming wrong. So this is what I learned this week. Yeah. Okay, thank you very much.
Okay, maybe one last questions. Yes, go ahead.
Thank you for the opportunity. I'd like to introduce myself. My name is Leonard Sean. I'm from mechanical engineering in Gajah Mada University, same as my colleague here. I'd like to address a question to Mr. Coyle. Forgive my my lack of knowledge, my ignorance for this topic, but I'd like to ask a few questions because from my understanding of classical securities, through hashings, through cryptographic verification, there is a way where quantum mechanics can actually bypass this mechanics that we have been relying on this whole time to verify each other's informations. Is there any way to combat this in quantumly? Maybe I'm not too familiar with it. Please explain. Thank you.
Thank you very much. This is very interesting and very good question, everybody. So, okay, let's say that we have the three parts. So the first, classical cryptography. Now we are using, for example, in Zoom or in our current communication, we are using classical. And mainly for the classical, we are using RSA algorithm. The second, we have the quantum algorithm, and the quantum machine, quantum computer can break all the cryptography of the existing, almost all. Maybe if some cryptography are still unbreakable, someone from the quantum guy, maybe they can develop algorithm, we can also break that one. So that's why it is dangerous by 2030 if you don't prepare this one. And World Economic Forum already warned us that time. And then the third is the post-quantum cryptography. The post-quantum cryptography is the classical cryptography, but it's being designed to be strong against the quantum computer. So now everybody is researching on that. Even though some post-quantum cryptography currently is still weak, and even the very conventional computer can break. It is released by IEEE just I think 3 months ago or 4 months ago, that the current post-quantum cryptography is still weak. What my laboratory is doing is both. So we are developing quantum cryptography and we are also developing post-quantum cryptography. Why? Because in some sense, with the current limitation of our computer, we need the classical cryptography. But the current classical cryptography should be strong against the quantum computer. But maybe in the future, quantum computer can also break again. So we should think again later. So like that. So the first, we should move to post-quantum cryptography. Don't try to be always in the classical. Move to the post-quantum cryptography. For example, lattice-based classical cryptography. This is one of the techniques that quantum still need time. Or someone need to develop the quantum algorithm like Shor algorithm to break the lattice cryptography, lattice-based cryptography. The second is that everybody, I think you should also work on the quantum cryptography because this is very secure. When I develop, first I do not believe too that is it really secure. And then after I know how it works, and then I also believe that it is also secure. But the funny question it is from our ministry. If the corruptions, is using communication based on quantum, how we can intercept? Even I said, okay, I don't know yet how to intercept the quantum based cryptography. Okay, so thank you very much. I do hope that it answered the question.
Okay, thank you very much, ladies and gentlemen. That's our sessions for this afternoon. I would not conclude or summarize what we have discussing this afternoon. But what I can say is that physics is an important basic science for us, mechanical and electrical, as well as telecommunication engineers. For get good understanding on that, we need another basic, that's mathematics. So don't be afraid for physics and mathematics. Okay, thank you very much for our speakers this afternoon. Let's give them a big applause. Okay, thank you very much. And the time goes back to Ms. MCs. Thank you.
So thank you very much for Mr. Sudarisman for chairing this plenary session. And we also would like to thank to Mr. Khairul Anwar and Mr. Muhammad Ahsin Muflihun for your presentation. We would like to give a souvenir from Faculty of Engineering that will be given by our Dean of Faculty of Engineering, Universitas Muhammadiyah Yogyakarta, Mr. Aris Widyo Nugroho, PhD. To Mr. Aris Widyo Nugroho, please come forward. The first souvenir will be given to Associate Professor Dr. Khairul Anwar from Telkom University, Indonesia. And the second souvenir will be given for Mr. Muhammad Ahsin Muflihun, PhD from Universitas Gadjah Mada, Indonesia. All right, we are going to have a photo session. So to all the attendees, please come forward. We are going to take a picture with our keynote speakers. Silahkan mau, oh saya di depan aja. Sing paling tinggi, paling pendek. Okay, thank you very much. You can go back to your seat. Thank you once again to Mr. Sudarisman, Mr. Khairul Anwar, and Mr. Muhammad Ahsin Muflihun.
Sudah siap itunya belum? Sertifikatnya? Nggak tahu, saya tanya.
Oh. Together, and this event is about to come to the very end. I hope you found the presentation at this conference are informative and helpful. Now, we will announce awards for the best presenters from 3 focal conferences, ICITAME, IC3IS, and IROSIP. For ICITAME Best Presenter announcement, there are 5 best presenters here from 5 rooms, 2 from online rooms, and 3 from offline rooms. The first one, Aulia Fasana Hadining, with the title Factors Influencing Actual Adoption and Utilization of E-Government in Governance Institution. The second one, Gregorius Arya Pandita Wicaksana, with the title Designing an Enterprise Resource Planning System in Reverse Logistics to Support the Circular Economy Concept. And 3 presenters from the offline room. The first one, Anita Rizky Triwidyanata, with the title Investigation of Space Frame Models as Long-Span Beam Replacement. Abdullah Irfan, with the title Cellulose Chitosan PVA Nanofibrous Membranes for Air Conditioner Filter Material Application. And the last one is Widi Astuti, with the title Anomaly Detection on Natural Gas Operational Data Using Variational Auto Encoder. To all the best presenters who attend offline conference, please come forward to receive the award. And we would like to invite Mr. Teddy Nurcahyadi as the chairman of Ichitame to give the reward, please. Yeah, please, for the best presenters of Ichitame, for the offline presenters, please come forward to the stage to receive the reward from our chairman of conference. Citame ada 3. 3 aja. 3 aja? Citame ada berapa? 3. Ada 3. Yang 1 nggak datang. 3. Oh ya, oke. Thank you very much and congratulations for the best presenters of Ichitame 2023. For the next is the best conference, the best presenters of IC3IS. There are so many room tracks here and there are 2 offline room. And I really hope that all the presenters are coming here so they can receive the reward, while the other are from online room. Let me mention the first one, Cites Dundas, with the title, A Computational Approach to Understand the Human Thought Process. The second one, Lobna Halet, with the title, Design of a Double Pass Shell and Tube Heat Exchanger for Marine Application with COMSOL Multiphysics. The third one, Jaka Raja Kumar, with the title, Blockchain-Based Traceability in Computer Peripherals in University Scenarios. The next one is Gabriel Christie, with the title, Social Media User Awareness toward personal identifiable information's data security in Indonesian millennial generation. The next one is Mutiara Salsabila Putri with the title Designing Dashboard for Procurement with Circular Economy Concepts based on Enterprise Resource Planning. The next best presenter here is from the offline room 1. It's Mr. George Wu with the title Geometric Distortion Detection Infused Filament Fabrication Using Augmented Reality and Computer Vision. The next one is from the online room, Jesslyn Audrey with the title Heart Attack Prediction Using Machine Learning Classification Models. The next one is Chris Kalia Mayangkari with the title Yogyakarta Electricity System Expansion Planning Considering Renewable Energy and CO2 Emission Reduction. The next one is Rudy Cahyadi with the title Analysis of Budget Submission Process at System Block Back Office Selindo using the TAM model. The next one is Muhsin Hasanu with the title Energy Aware Clustering Routing Protocol for Dense Underwater Acoustic Wireless Sensor Network. The next one is Haula Nurdin with the title Applying the Circular Economy Concept in Sales Management Dashboard at MSMEs using ERP systems. The next one is from offline room 2. I hope that the presenter is here. Miss Sinta Novanana with the title 5G Lab as a Service, Simulator Deployment, Study Case Scenarios in Indonesian Higher Education. The next one is from the online room, again, Zawad bin Saif with the title EEG-Driven Age Prediction, Advancements in Machine Learning Models. Rara Dwi Octaviani with the title Two-Axis Feedback System for Radio Sound Antenna Tracker Controller. Albert Sagala with the title Exploring Vehicle Tracking Performance with LoRa Technology, an analysis of speed and environmental factors. And the last one is Agus Pratondo with the title Classifications of Lettuce Leaf Variants Using Transverse Learning. To the offline presenters, I hope that you are here. Please come forward, and the reward will be given by our Dean of Faculty of Engineering, Mr. Aris Widyo Nugroho, PhD. So, to the best presenters and also Mr. Aris Widyo Nugroho, please come forward. Thank you very much. You can go back to your seat. And for the last best presenter here is from IROSIP. All the best presenters here are online room. So let me mention one by one. The first one, Mohd Firdaus Abdullah with the title Automated Torque Classification System in computed tomography images using deep convolutional neural network. Tirda Febrilian Putra with the title Electronic Nose with Artificial Neural Network Method on Raspberry Pi 4 for detecting pork and bee. Mr. Anis ul Husnain with the title A Study on the Effects of Increasing Obstacles on Past Generation Time, Energy, and Steps Count using Rapidly Exploring Random Tree Algorithm. Andi Sharwani with the title Determine Traffic Accidents Based on Changes in Driving Patterns. Meet Parmar with the title Hybrid Force and Position Control of THRQKIWA Robotic Manipulator. Wahyu Kusuma Atmaja with the title Prediction of Internet Broadband Connectivity Classification in West Java, Indonesia using machine learning. Agus Pratondo with the title Classification of Water Apple Leaf Varieties using Transfer Learning. Darwindra with the title Machine Learning for Space Information Speech in Emotion Recognition. Jesse De La Cruz with the title Predicting the Rooftop Solar Energy Potential of the City of Manila using an Artificial Neural Network-based system utilizing geographic features. Christian Nash with the title ADHD Mental Health Symptoms Detection based on Facial Landmark Tracking. Muhammad Fajrul Faiz, Yesi Jusman, and Ahmad Zaki with the title Classification of Building Structural Fragility Levels with machine learning based on Hu and Zernick moment invariant methods. And the last one is Mayur Rele with the title A Smart Intravenous Infusions During System. So congratulations for all the best presenters of AeroShips. To the online presenters, we will send the certificates when it's ready. Thank you very much and congratulations. For your information, that the best paper and best video presentation will be announced in the ICOSI closing ceremony. And now, to the end of the day, I would leave you with a quote by Stuart Brand, an author and innovative thinker who once said, "We can see the past but not influence it. We can influence the future but not see it." Let us all be guided by all the things we have learned and heard throughout the conference and be able to see and influence our future. Thank you very much. After this, you will be guided to join the ICOSI closing ceremony in AR Fahrudin in the 5th floor building by the committee. Thank you very much and wassalamualaikum warahmatullahi wabarakatuh.